Welcome back to VTU e-Shikshana program on computer aided engineering drawing. We are working on model 2 where solids are dealt with different positions, particularly the solid rests on HP inclined to both HP and VP. Now, we will take a problem. A square pyramid of 40 mm base sides and height 70 mm has one of its slant face on HP such that its axis inclined at 30 degree to VP. I have highlighted slant face. It can be slant edge also. I will explain with a simple model what exactly slant face and slant edge. Now, first let us work out for the slant face on HP. Normally, we will have the edge on HP inclined at some degree to the axis inclined some degree to VP. Edge on base edge on HP, axis inclined at some degree to HP, or the slant face containing the base edge on HP is inclined at some degree to VP, that you can do. But in this case, he says the slant face on HP. He never says it rests on HP with its base edge or corner. No, we have to decide what exactly the first position. So, for information, if this is the case, edge condition, then only you can rotate and keep the slant face. This is the slant face, triangular face on HP. For all pyramids, slant faces are triangular faces. First position, second position. Then they may give a reference, the base edge on HP is this, inclined at 45 degree to VP or 30 degree to VP, or axis inclined at 30 degree to VP or 45 as usual for the other problems. Now, base edge on HP means this one. Okay, it need not be like this, it can be like this also. The triangular face, slant face, one of the base side is the base edge only. So, that base edge is inclined at some degree to VP. This is true length and true inclination like this. First position, second position, third position. In case of axis, if they give appears to be take the true angle, axis already inclined at some degree to HP, it is not given. Once slant face is on HP, definitely axis assumes some inclination to HP, you have to check for the top view of the axis. If top view of the axis is foreshortened, that is apparent length, then definitely you must consider beta, because apparent length and apparent inclination. So, this problem deals with the base edge to be placed like this on HP and then rotate. So, the base edge must be placed perpendicular to VP and rotate like this. Okay. So, this is first position, second position. Then the axis is already inclined to HP. Once slant face on HP, definitely axis inclined, but very small angle, around 30, less than 30, it depends on the size. Anyway, it is inclined, correspondingly get apparent length. That apparent length must be placed on apparent inclination. Okay. So, in this problem, axis is given directly, we have to find beta and then redraw the figure. Suppose that instead of axis inclined at some degree to VP, if they give base edge on HP is inclined some degree to VP, true length and true inclination, because this on HP inclined only to VP. So, to start with, we have to have the top view edge condition, but suppose that if they give instead of slant face, slant edge, then you must have corner condition, first position, second position. The diagonal passing through the corner to be placed on HP is always parallel to VP in for all even number of sides. First position, second position. See, this is the slant edge, this is on HP, and the two sides makes equal inclination with HP and also VP initially. In this case, it becomes different if it gives inclination to VP for the axis. Now, for the second case, case 2, the initial position is corner position, then incline, then you can see the slant edge on HP. In this case, the previous case it is slant face, completely surface is on HP, triangular surface. Here the longer side, this one longer edge, in case of prisms we say longer edge, here slant edge is on HP for that corner condition. That means I will just write to information slant face on HP means you have to have edge condition edge condition, slant edge means on HP means that refers to corner condition. Corner condition, that is all. You have to have this in mind and then proceed. Now, let me work out first problem. So, you know very well that this is the problem on edge condition. The edge to the edge must be, one of the base edge must be perpendicular to VP. So, that if you rotate it, you will get the slant face on HP. So, this is how you can complete. You can choose in computer the rectangle by 2 points and complete it. Here you can use any method to complete the figure. So, draw top view, with the given data, and also you must dark the diagonals that represents slant edges, dark lines only, unlike prism. This is VO, this is corner naming, left extreme nearest corner, start, and visible points, then invisible points. Keep the dimensioning properly. This is 40 mm and height 70 mm. So, you can take this projection up. So, 70 mm height, then first draw the axis, fix this V vertex, V dash, this is O dash, O dash, join these two. Concept of visibility, whenever a surface is perpendicular to VP, this line is, this surface is represented by line, this is triangular surface, this particular line representing triangular face or slant face, okay. Now, dark this. Yes, we have completed the front view. Dimensioning, proper dimensioning always requires. So, it is 70. Now, I have to concentrate on this. The triangular face containing the base edge to be placed on HP or on HP. It never says it is to be placed, it automatically comes with that. See, whenever slant face on HP, this is part of slant face, base, one of the base edge, that base edge is part of the slant face. So, first position, second position. Now, I have to redraw this figure such that B dash C dash, this is A dash D dash. You can do like this also, same thing, first position, second position, or first position. So, normally we move forward. So, keep the B1 C1 or sorry BC, no prism business, it is only BC. BCV is the triangle that should be placed on that. This line is representing the triangle BCV, okay. So, isosceles triangle that should be placed there. So, you redraw it, that is all. In computer, move and rotate. In this case, it is very easy, arc method. You take this BC distance, BC distance here, okay, with you name this as B dash C dash, and this is V dash. Same distance, with the same distance you draw one more line, that arc with the same radius, because these two are equal, symmetrical because of the symmetry. Then take the base length, cut an arc, that is all. So, with this base length draw an arc, then gets you the second figure, front view, ready. That is all you have to do. So, irrespective of the shape, if it is hexagon, pentagon, everything is, but pentagon and triangle you have to be very careful. The axis is biased towards right or left, all depends on the slant edge on HP or slant face on HP. In this it is symmetry in case of hexagon and square. So, easy. Now, mark the center O dash V dash. Now, I always prefer to have V and O instead of O1. I will justify that with a particular problem in future. Okay. Now, here is the observer. Okay. Now, assume that this is HP and this is the position. You cannot see the true shape, you can see the color, apparent shape, very small size of base. Okay. Unlike this, you can have, if this is the case, you can see the color. So, definitely this base is visible, but not true shape, apparent shape you get. So, project it and get the corresponding top view. See, apparent shape you get very small size, you get, that all depends on the length of the axis, height of the axis. Okay. Now, be careful, this is B, this is B, this is to be named B, this is A dash D dash, this is A, this one is D, this one is C. So, what happens many times normally, we look at this and then write AB and DC, then the figure will looks like same thing, but final figure, final print will go wrong. I will show you how exactly this particular problem arises and how it looks like. So, on computer software. Here let me go ahead with the procedure. I am insisting on this 2 points, this is BC, this is AD, join this all these points in order. Okay. Now, visibility, concept of visibility. Here the farthest item concept may not work here according to me, because farthest item from you is the triangle BCV itself is the triangle. So, that is visible boundary actually. Okay. And the boundary lines, yeah, this is the farthest item is BCV, BCV is not visible, but boundary is visible, that boundary is visible, yes it works, but it leads to confusion totally. But the key surface concept is very easy. See, this surface, even though it is inclined, it is facing the observer, you can mix both, no problem. This surface is facing the observer. Suppose that if I keep this, I have the white color and also, yeah, assume take this one, this is white color, this is blue color. If you look from this direction, you can see blue color surface, no doubt. So, here also same thing, I have kept this way, you can see small area of this color. Okay. So, definitely the base is visible to the observer. So, visible key surface dark the visible key surface, because that surface is towards observer, facing observer also. Okay. Now, boundary lines dark, boundary lines dark. Okay. Now, what about this is V dash, what about CV and BV, it is crossing the invisible surface, definitely this is invisible, or already a visible line is there, this must be invisible because of crossing line. So, no bends works here. Okay. So, visible basic concept, visible surface, invisible line, that is all. Now, let me take different color for that, black color, and draw so that you can realize. Yes, this is invisible, this is invisible because this is crossing visible surface. Okay. Now, let me go for the farthest point, farthest item. In the previous cases we had corner or edge, here the surface itself is the item which is farthest item because it is completely on the ground, all things are above the ground. This particular triangle is dotted. According to that concept, all are dotted line because these two are also connecting, but they are boundary lines. Okay. Now, the surface is nearer to the observer. Okay. So, what exactly is the concept is visible surface, invisible line. Now, go for the axis representation. Yes, this is O, then O1 must be identified with thin line, with line hyphen. So, this is from this point to this point, OV is the axis. Now, OV is apparent length, OV is apparent length. Since he has given axis itself for the inclination to VP, I am concentrating on that. Suppose if he says base edge on HP is inclined at some degree to, which is the base edge on HP? BC. BC is true length and true inclination. You redraw this figure such that BC is inclined at some degree to VP and get the corresponding front view. Now, since he has given directly the axis inclined at 30 degree to VP, already axis inclined at some angle theta, definitely this is apparent length, this is apparent length, then you take true length and apparent length, separately you can do better. So, this is true length of the line, axis VO1, then draw a line, then take apparent length, mark. Direction is not important, anywhere you can keep. This is VO. So, VO is apparent length, VO1 is true length. This is true length, this is apparent length. This is actually inclined 30 degree to VP. So, this becomes beta. So, you will get some value like 41 or something, that depends. Okay. Now, how to redraw it? You know, draw this line inclined at some angle beta, whatever the value you get, and then redraw the figure. So, for redrawing figure you can use the specific geometry reference, okay, and draw it. Draw perpendiculars. If you draw two perpendiculars, that works for completing the figure. See, if you take only one distance, draw perpendiculars at this distance. If you measure from O to V, okay. Now, take this distance, that works for 4 points, then join them, that is all. Perpendicular line, yes. So, assume that this is beta. Now, keep this line. Same figure you must redraw, draw the figure as per the second figure top view, visible and invisible lines, because same thing you are redrawing. Because of less number of sides we can do it, otherwise it becomes clumsy or number of lines will coincide and then give something else. Now keep this axis reference, this is O. Now project all this. The first thing is you have to find beta. Suppose if he says appears to be, then take directly. Now name these points carefully, A, B, C, D. Okay. Project it one by one. Which is on HP? You have to be very careful. BC on HP. So BC. This is C dash, this is B dash. Then AD. This is A dash, this is A dash, this is D dash. Now join this. Okay. Now this is V. Project it and get V dash. Then I told you, you better keep VO instead of O1, because many times what happens, people project simply this and get confused with this VO, this as O, and then if they mark O, they mark here, then join this way. No, this is wrong. Always keep this particular naming as we, not always, majority of the time they do it. Out of 75% they do this mistake if they keep O1. But V if you keep, you never do that mistake, because V is different, O is different. O1 always confuses you. So now V is very much on the XY line, because V is here. Now mark it here, join them. AV, DV, C and B definitely single line. This particular area rectangle if I take, if you look at this, all four corners on the ground only. Okay. Now that is why this is represented by a single line. Now complete the final front view. I am here, base is nearer, not that in top face base is visible, no, base is towards observer, it is nearer to the observer than apex. So base is visible, base surface is visible, dark this base surface. Then boundary lines are dark. What about this line? Visible surface, invisible line, very easy to identify. Visible surface, invisible line or crossing line. Okay, it's very easy to understand. Now identify the axis. This is O dash, this is V dash. Join them with a suitable thickness, that is 0.25 or 35 in computer, otherwise medium line in manual drawing. So this is how you complete the solids problem when slant face on HP. Now what happens when it slant edge on HP? I repeat and give some hint for you how to proceed. First position, second position, the corner condition you should take, then it becomes solid edge, sorry, the slant edge in on HP. First position, second position. Okay. So you must follow specifically corner condition with diagonal parallel to XY line. I will give sketch, simple sketch. Okay. This is top view. This slant edge projection, basically diagonal I refer, basic. Then you get the corresponding front view like this. I concentrate on A, B, C, D. VC is the reference for me, VC, V dash C dash is the slant edge, that will be on ground, or C dash, this is V dash, you get this figure redrawn. Then you get the corresponding, definitely this surface is visible and the outcome is this. Now, the finally you get second figure top view like this. This is invisible. Now, you redraw this figure such that the axis is inclined at beta, same concept. You measure apparent length, this becomes apparent length, find beta, then redraw the figure. So, this is how you get the problem solved for this. Then you get final front view. Base is visible. You can take this away, then base is not visible. So, this is how you can complete the set of problems which are having slant face on HP, slant edge on HP. It may be triangle shape or pentagon or hexagon, any shape base you can carry out. Now, we will discuss the same on the computer software. So, here a problem on square pyramid is taken with 35 mm sides and height 60 mm or axis length 60 mm, rests on HP with one of its slant triangular face HP with one of its slant edges. Slant triangular face. If they say slant face, it is understood that it is triangular face. Draw the projections of the pyramid when the axis appears to be inclined at 47 degree. Normally they never give this 47 and all, but for some purpose we have taken. Okay. Now it is beta is given. Assume that it is given some angle like 30 or so, it will be beta 47. Otherwise they give 45, 30, etc. Now specifically I have colored the particular area that is called slant face in this case to highlight that. Blue color, you can see blue color is taken as the reference, that is actually triangular face. Now as I explained earlier, this must be edge condition for slant face, corner condition for slant edge. Here this particular line refers to the triangular face, that is BCO. Here O1 only is taken. I will tell you how the problem starts. Okay. So at the end I will show you. You always prefer to have VO. Now the figure is redrawn to place the slant face on HP. So here let me give some idea about this particular problem. Since the slant face on HP must have edge condition, the edge to be taken as a reference must be perpendicular, so that you rotate, you get the slant face on HP. That is what we have done. So in case of some inclination to the axis or the slant face inclined some degree to HP, you get edge condition only. Naturally this should be taken as this, and completely you rotate so that OBC is on the ground or HP. Now project it. You are here, observer is here, then this face is facing towards the observer, so that is visible. Then boundary lines dark, then visible surface, invisible line. Okay. Now you keep the axis properly. This completes the second figure, top view. First step, second step. Third step is, he has given, appears to be inclined at some degree to XY or VP in fact, or he may give top view of the axis inclined at 45 degree to XY or 47 degrees to XY. So beta is given here. So naturally you redraw this figure such that OO1 is on beta degree line. Then here base is towards the observer position is here, base is towards the observer. Now base is visible in front view. So start from key surface reference, visible key surface reference. Visible key surface is dark, then boundary lines are dark, then visible surface, invisible line. Suppose that if I take the reference farthest point from the observer, this is O. O is not visible. Okay. Any number of lines connecting to that are not visible. That means all these lines are not visible, but they are boundary lines. Then only one line is restricted for invisible line. Then all other lines are dark. That also you can do. But If we get confused, then you can do all this, crossing line, then bends, all those things. Here, bends have no place here, no scope for bends here, because we cannot have that. No such point which is having three lines joining together. So, whatever available basic concept you should use. So, this is a very simple job. Now, I will show you step by step. First, you draw the top and front views with edge condition. Then, you move and rotate this so that the slant face on HP. Then, the way you complete, you don't draw all these lines up to V, that is O. You restrict to the base only, then try to complete, because single line works for the apex. So, this is correct. Now, sometimes the people keep all the lines okay up to this, that is wrong. Now, here the visibility concept is given here. Top face, base is visible, and then completed. Then next comes this one. You have to redraw it such that axis is inclined at beta degree to HP. Base is nearer to the observer, so base is visible. This is right. Now, what possibilities are committing mistakes? See, what people do is, this is AD and DC. So here BC, they keep in the same sequence. This is AD and this is BC. That is wrong. Actually, this is BC. Now, if you do properly, you will get like this. Suppose that if you will do ulta, see, here I kept B, instead of BC, I have kept AD. And this is BC, but it is actually AD. If you do like this, you will get something wrong. See, somewhat odd figure you got. No, nobody knows. In that, at that situation, you may not know. Once you get the answer, you are happy, you come out. Just like you enter the garbage computer, you will get the output as garbage. Here also same thing. You do something, you get some figure, you are happy. But it's wrong, because you committed mistake here. So, such mistakes should be avoided. Okay, now, so I told you many times this OV business. So, this is O1 and all people take, and here it is different. The base is away from the observer. If you look from this direction, base is not visible, then boundary is visible, invisible surface, visible line. The total triangle is coincided with this line. Now, lastly, you have again same mistake people have committed. See, this is instead of DA, BC is there. Yes, see, the base is away from the observer. Still, they keep sometimes visible. It is wrong. Okay. Now, the way you work, instead of completing the projection lines up to this, you restrict only this. This is the only hint we are giving. So, this is how you can utilize the concepts and complete the problem. These are step by step again. This is the complete solution. Now, I will take up one more example of hexagonal pyramid and show you what exactly the problem is. Here is the problem on hexagonal pyramid of 25 mm side of base and 50 mm axis length on HP and one of its slant edges. Earlier we had problem on slant face for the square. Now I have problem on slant edge. Slant edge means corner condition. See this corner condition. In this case, when the axis is inclined to VP by 45 degree. So definitely this works out to be beta business. So you have to take beta. Okay. Now 45 degree line is there. 45 degree. Now I'll repeat the question. Hexagonal pyramid of 25 mm side of base and 50 mm axis length rests on HP and one of its slant edges. Draw the projections of the pyramid when the axis is inclined at some degree to VP, that is 45 degree. Here they never give that it should be corner condition. You must realize that whenever you want to have slant edge on HP, once you rotate, you must have corner condition so that the related line is to be the slant edge. So you draw the top and front views with the corner condition, project it, then rotate. Then you see that the axis length is reduced from 50 to 44.86. So he says directly inclined at some degree to VP. So whenever the axis inclined to both HP and VP, you must find out beta. So he has not given directly axis inclined at some degree to HP. Whenever the slant edge on HP, definitely axis assumes some angle. See here, this axis assumes some angle. Say in particular, I will give that value also. Okay, you not worry, because accordingly you get the apparent angle. Apparent angle you get, apparent length you get according to the angle of inclination. Now it is around 27 degrees. Yes, so it is inclined at some 27 degrees. So naturally, 27 degrees is the corresponding value you get. Now he has given the value of true inclination to VP, that is 45 degree. You draw 45 degree line, take true length. AB2 is true length, that is 50 mm. Then AB is this. Okay, instead of AB you can keep PQ or something, because it leads to confusion. Okay, so it is better to have some different naming. Because AB and all are representing something else here, it is better to have PQ, otherwise O1, etc. P, Q, R. So small PQ represents the true length and PR represents apparent length. So that's all. Now, after getting beta as 52, you take 52 as a reference, redraw this figure such that it is inclined at, axis inclined at some degree to VP, beta degree to VP. Before that, let me clarify the concept of visibility. You are here, then definitely this base is facing towards the observer, face is visible. Okay, then the only the edge on HP is longer edge or the slant edge DO. DO is not visible. Any number of lines connecting to that are not visible in case of farthest point, but boundary lines are visible. To avoid confusion, what you do is the key surface concept. Key surface is visible, dark it. Then boundary lines dark. Then remaining lines can be completed using bends or crossing line. Okay. Then what about DO? DO, part of DO is covered by AO, visible line. First preference for visible line, then invisible line. Then even if you draw dotted line, never seen. So from this point to this point, see A to D portion only is available for OD. Complete OD is not presented here because the preference is for the visible line. Naturally, scope is only for this area and this to this point. Now the hidden line DO, that is the farthest point. Next, here, let me take this. I am here, then base is near to the observer, base is visible. Then boundary line is dark. Then this is visible surface. Through that there are three lines moving, that is edges EO, FO and AO. All are invisible because visible surface, invisible line. Then what about CO? CO is not having any line, it is having the reference bends. See, this line is dark, this line is dark, one more line joining that also dark. Otherwise, you can have all the farthest item from you, again it is O, and this is bends. All remaining edges are dotted. Okay. So what about this line? This is also connecting, it is not on boundary line. For that, we will have this key surface reference for these type of problems. Okay, otherwise if you are happy with the farthest point and you can imagine and do it, you can do it. But best thing is key surface reference is very easy. See, visible key surface dark, boundary lines dark, bends, crossing lines. That's all. Okay. So this is about the overall answer. Now I will go by step. First position, corner condition. Second position, you rotate that completely so that dA on the ground. Then you restrict only to the base surface. Don't project all these points up to this. Okay. So you can have either this type projection or this type, because here we don't have any job here. We have only these 2 points. So project only. That all depends by experience you get, how much to project and what to project, what not to project. Then, and people completely draw all this. That all depends. Even if you can do it, but you should have time and patience. So this is not at all, advisable, because people simply keep till their home, draw a number of lines beyond the requirement. Now, project and get the visible surface, and then boundary is dark and crossing lines, etc. After completing the beta value, then you redraw this figure such that O1 is on beta degree line. Do this. Then project. So here observe, I have taken D. Here D is there. If you rotate, D will be here, and O, DO, D matching, and then OA matching. Sometimes people do ulta. See, here AD is there, people taken AD in sequence. No, here is D. This must be D, not A. See, this is D, this is not A, this is D, this must be D. So whatever is available here, simply take blindly. Then you get some awkward figure. They never feel that it is awkward because they feel that it is some figure, but it is not correct. So because of this change, you get different shape, not correct answer. So you must be very careful. This must be D, this is A. Accordingly, you do it. Think twice with this type of typical problems like this. Okay, now, in previous case I had the base towards observer, okay, base towards observer, and got the base visible. Now, in this case, base is away from the observer. Definitely base is not visible. Boundary is dark, invisible surface edges other than boundary lines are dotted, invisible surface, visible lines, all ulta. So previous whatever you had, that becomes ulta, except boundary lines. Now, we have some typical cases where you commit mistake by drawing visibility wrong. See, base is away from you, still people draw dark, because in top face it is visible. They think that is all because the apex is nearer to you, not the base. Base is away from the observer. Assume that this is red color base, these are all white or some other light color. The red color base is not visible if you take away from the observer. So that also I have demonstrated earlier. Now, this is one type of mistake people commit. And lastly, as I told you earlier, if you take O1 as the reference, blindly they project O as well as O1 on this line only. Okay, so this is the common mistake I have seen. Okay, so avoid keeping O1, always keep VO, because V is on the ground and you never commit such mistake, because O reference is always dangerous for both. So this is what I wanted to give information. So next sessions we will work on cylinders, cones and related problems.